This lesson covers two different methods regarding how to convert a fraction to a decimal number. Let's start with the easy method first and look at the fractions 3 over 10, 5 over 10, 7 over 100, 11 over 100, 13 over 1000, and 17 over 1000. What do all these fractions have in common? They all have a 10 or 100 or 1000 in the denominator. They also could have a 10,000 or 100,000 and so on in the denominator. If you have these kind of fractions, it's very simple to convert them into decimals. Why is it so simple? Let's first focus on the fractions with the 10 in the denominator. A 10 in the denominator is the same as dividing by 10, which in turn means that you shift the decimal point from the numerator one place to the left. But where do we find the decimal point for a whole number like 3? You can think of a decimal point right after the 3. Because 3 is equivalent to 3.0. So shifting the decimal point from 3.0 one place to the left gives us a 0.3, which means the fraction 3 over 10 is 0.3 as a decimal. We can do the same with 5 over 10. 5 is equivalent to 5.0. 5.0 divided by 10 means again shifting the decimal point one place to the left, which gives us 0.5. So the fraction 5 over 10 is 0.5 as a decimal. Let's look at the fractions 7 over 100 and 11 over 100. These two fractions have 100 in the denominator, which means dividing by 100, which in turn means we can move the decimal point 2 places to the left. So the 7, which is 7.0, becomes a 1, 2, 0.07. As a decimal, and the 11, which is 11.0, becomes a 1, 2, 0.11 as a decimal. Let's look at the fractions 13 over 1000 and 17 over 1000. In this case, we have 1000 in the denominator, which means the 13 becomes a 1, 2, 3, 0.013. 0.013, and the 17 becomes a 1, 2, 3, 0.017. 0.017. Let's recap. We divided by 10, by 100, and by 1000, and then shifted the decimal point of the numerator 1, 2, and 3 places to the left. Do you see a pattern here? When the denominator was at 10, which has 1, 0, we shifted the decimal point of the numerator one place to the left. When the denominator was 100, which has 2 zeros, we shifted the decimal point of the numerator 2 places to the left. And when the denominator was 1000, which has 3 zeros, we shifted the decimal point of the numerator 3 places to the left. But what when we have fractions like 1 over 2, 3 over 4, 3 over 5, 3 over 8, 36 over 200, and 21 over 300. All these fractions have neither tens nor hundreds nor any ones with zeros in the denominator. In this case, we have to convert them into a fraction with a 1 and zeros in the denominator. We call this method converting fractions to higher or lower terms. If you don't know how to do that, please check out my 2 previous videos simplifying fractions to the lowest term and changing fractions to higher terms. Let's try the example 1 over 2. The easiest way is to make a 10 out of a 2. So 2 times 5 is 10, and 1 times 5 is 5. Now we have 5 over 10, which is what we wanted. We have 1 0 after the 1, so we shift the decimal point of the numerator 1 place to the left, and we get 0.5. So the fraction 1 over 2 is 0.5 as a decimal. Let's look at 3 over 4. Can we multiply the 4 with the whole number to get 10? Unfortunately not. Can we multiply the 4 with the whole number to get 100? Yes, we can. 4 times 25 is 100, and 3 times 25 is 75. So we get 75 over 100. 2 zeros after the 1 in the denominator means we shift the decimal point in the numerator 2 places to the left. 75.0 becomes 1, 2, 0.75 as a decimal. So the fraction 3 over 4 is equivalent to the decimal 0.75. 3 over 5 looks easy. 5 times 2 is 10, and 3 times 2 is 6. So we get 6 over 10. 1 0 after the 1 in the denominator shifts the decimal point from 6.0 1 place to the left, and we get 0.6. 3 over 8 is harder to solve. Can we multiply the 8 with the whole number to get 10? Unfortunately not. Can we multiply the 8 with the whole number to get 100? Unfortunately not. What about 1000? Is 1000 divisible by 8 without a remainder? Yes. 8 times 125 is 1000, and 3 times 125 is, let's see, 125, 250, 375. 375. So 3 over 8 is equivalent to 375 over 1000. 3 zeros after the 1 shifts the decimal point from 375 3 places to the left, and we get 0.375. So 3 over 8 is equivalent to the decimal 0.375. Let's look at 36 over 200. In all our previous examples, we raised the fractions to higher terms. But in this example here, 36 over 200, it's easier to simplify the fraction to lower terms. 200 divided by 2 is 100. And 36 divided by 2 is 18. So we get 18 over 100. With 2 zeros after the 1, we shift the decimal point of 18 2 places to the left and we get 0.18. So the fraction 36 over 200 is equivalent to the decimal 0.18. Let me show you how we can also solve this by raising the fraction to higher terms. Which number with a 1 and zeros can be divided by 200 without a remainder? 1000 is the next number. 200 fits into 1000 exactly 5 times. So 200 times 5 is 1000. And 36 times 5 is 5 times 6 is 30. Write the 0 and carry the 3. 5 times 3 is 15. 15 plus the carried 3 is 18. So we get 180 over 1000. So 3 zeros after the 1 in the denominator. So we get 0.18, which is the same answer we got when we solved this problem by simplifying the fraction to lower terms. The more experience you have, the faster you will see which way works best for you. Anyway, both raising fractions to higher terms or simplifying fractions to lower terms work. What about our last example? 21 over 300. Here we see that we can easily convert the denominator 300 to 100 by dividing by 3. So 300 divided by 3 is 100 and 21 divided by 3 is 7. So 21 over 300 is equivalent to 7 over 100. The 2 zeros in the denominator shifts the decimal point from 7 2 places to the left and we get 0.07. So 21 over 300 is equivalent to the decimal number 0.07. Unfortunately, we can't always raise our fractions to higher terms or simplify the fractions to lower terms to get a 1 with zeros. Let's look at these kind of fractions. 1 over 3, 5 over 6, and 7 over 11. In these cases, we have no choice but to bite the bullet and convert the problem to a regular long division problem. We'll divide 1 by 3, which is equivalent to 1 over 3. In other words, we have to realize that 1 over 3 is nothing else than division. The multiplication table is a must-know for long division, so learn it as fast as possible. It's very simple. Let's go back to our problem. The first thing we have to do is rewrite the division problem with the special division symbol for long division. Then all we have to do is just divide using the long division and we are done. Start by asking yourself how many times goes the 3 into 1. 3 goes into 1 0 times. Write the 0. 0 times 3 is 0. So subtract 0 from 1, which is equal to 1. Now we bring down a 0, which means we have to put a decimal point. Or in other words, you can memorize that by bringing the decimal point behind the 1 above the line, because 1 is equivalent to 1.0. Now we divide 10 by 3. The 3 fits into the 10 3 times. 3 times 3 is 9. Write the 9. subtract the 9 from 10 and we get 1 again. Bring down a 0. The 3 fits into the 10 3 times. 3 times 3 is 9, write the 9, subtract 9 and we get 1 again. We see that the pattern is repeating, so if we kept going, we would just get never-ending 3's here. We put a line over the digit that is repeating forever. So we see if we have a pattern like this, which is repeating, we can stop. The fraction 1 over 3 is 0.333 repeating. Let's look at 5 over 6. Here we have a 6 in the denominator. The number 6 is similar to our number 3 in our previous example. We have to memorize that we can't raise these numbers to higher terms like 10, 100, 1000 and so on. So we have to do the traditional long division to get our decimal numbers from these fractions. Let's write our fraction 5 over 6 again with the other dividing symbol. And ask ourselves how many times we can fit the 6 into 5. 0 times. 0 times 6 is 0. Write the 0, subtract 0 from 5 and we get 5. Bring down the 0 and put a decimal point. Now divide 50 by 6, which is 8. 8 times 6 is 48. Subtract 48 from 50 and we get 2. Bring the 0 down. 20 divided by 6 is 3. 3 times 6 is 18. Subtract and we again get the number 2. And now we see that the pattern is repeating again, so we can stop here. The fraction 5 over 6 equals 0.8333 repeating. What about 7 over 11? 11 is also a number which we can't raise to a 1 with zeros. So let's do long division again. Feel free to pause the video and try it by yourself. Again, how many times can we fit 11 into the 7? 0 times. Write the 0 exactly above the 7. 0 times 11 is 0. Subtract 0 from 7 and we get 7. Bring the 0 down and put a decimal point after the 0. How many times fits the 11 in the 70? 6 times. 6 times 11 is 66. Subtract 66 from 70 and we get 4. Bring the 0 down. The 11 fits into 40 3 times. 3 times 11 is 33. 40 minus 33 is 7. We see the pattern is repeating again. But we have to recognize exactly which pattern is repeating here. The pattern which is repeating here is not just the 3, but both the 6 and 3. So the fraction 7 over 11 is 0.636363 repeating. Let's do a quick recap. We looked at two methods above how to convert a fraction to a decimal. The simple method is when you have a 1 with zeros in the denominator, or when you can raise or lower the denominator to a 1 with zeros. In this case, you just shift the decimal point from your numerator as many places to the left equal to as many zeros that you have after the 1 in the denominator, and you're done. Again, shift the decimal point from your numerator as many places to the left equal to as many zeros that you have after the 1 in the denominator. When you don't have a 1 with zeros in the denominator and you can't raise or lower the denominator to a 1 with zeros, then you have to do the regular long division to get the decimal number of the fraction. If you have any questions, feel free to ask me in the comments. This video is what I did for you. If you want to do something for me, hit the bell button, share and subscribe. Thanks for watching and happy learning, everyone.